the relative humidity I talked about. So relative humidity is the ratio between the water vapor right now into the atmosphere you have divided by at that temperature that air can hold maximum amount of water vapor. So that's the ratio. So relative humidity depends on the temperature. So relative humidity increase, it means it is going closer to the dew point temperature. So if you look over here, diurnal variation of relative humidity, that's when you have the red line over here, you have the blue line. So blue line is telling you the relative humidity and the red line is telling you the temperature, which means that is the standard day. No additional atmospheric moisture is being added to the atmosphere, or no water vapor content actually taking away from the atmosphere. So in the morning we know that it started with the midnight. So midnight our temperature is here, relative humidity is here. So from the midnight to in the morning our temperature become lowest. You see the relative humidity is highest in the morning because the temperature is lowest. As sunlight gives sunlight insolation, temperature started to rise. You see the relative humidity is going down. As temperature rises, going down. At noon the temperature is not the highest. At 3 o'clock, 3 p.m. or 4 p.m. It's actually become maximum temperature because you have incoming solar radiation. At the same time you have terrestrial infrared radiation. So both together coupled and make maximum temperature of the day, and you see at that time your relative humidity is minimum. So the relationship between temperature and relative humidity are inversely related. So in the moisture chapter, those terminology and the real fact are important. So you must have some lectures on the formation of fogs. So 4 kinds of fogs, those are important. So we have 2 questions in your exam based on this precipitation and fog, all these things. So I will go through each of the formation of the fog, and you need to pick up the sense from here and answer the question during the exam. So radiation fog first. How radiation fog actually form. You know that in the daytime the earth surface actually heated up a lot because the earth has the mud or the dry earth, it has lower specific humidity, so it's heated up very fast. And also at night when the sunlight is not present there or insolation is not present there, and there is a terrestrial radiation, and that terrestrial radiation actually make cool. So that why during the night time, due to the terrestrial radiation give off the heat, give away the heat, and that's cool down the earth's surface, and adjacent to the earth's surface is become cold, and that cold means temperature lower down, create relative humidity increase and reach out the dew point temperature. So in this here we have that types of fog, and you will see these types of fog in the morning and sometime in midnight too, and some field that you go there, in some places that the temperature lower down during the night a lot compared to the daytime and the earth's surface, so you will get the radiation fog. So advection fog is something that advection means that horizontal movement. So fog is creating, and that fog is moving from one place to another place. So this advection fog initially can produce by radiation fog, evaporation fog, or upslope fog, but that has to be moving from one place to another, and the wind actually carry from one place to another. That's advection fog. And you see the another fog, the upslope fog. that actually depends on the elevation change, when the air is actually bringing the moisture content to the upward to the hill. And when we know that when you go all the way up, the temperature actually decrease. That's mean relative humidity increase when temperature decrease, and condensation begin to occur. And these types of fog happens due to the uplift of the air with the moisture content. So that's upslope fog. The evaporation fog is a very interesting fog. If you are going to some lakes, some pond, you see the water has the higher specific heat. So water need more time to heat up and also more time to cool down. So during the night, the air adjacent over the water body, that's actually this air become cool down. And when the hot water, comparatively hot water, evaporate, and instantly it mix with the air, cooled air above, and then the temperature decrease, relative humidity increase, reach out dew point temperature, and these types of fog form. So that's called evaporation fog. So again, you have two questions from here, so make sure that you know all these things. You may not have to answer in different way, but there's two questions from here. So you are familiar with form of precipitation. So we know that the difference between precipitation and rainfall. So precipitation is something that any falling object is falling from the sky. That's precipitation. So in terms of the water content precipitation, we have four types of precipitation: the rain, snow, sleet, and hail. So you need to know how rain form. We know that water vapor, moisture content with the water vapor goes up, and temperature decrease, relative humidity increase, reach out the dew point temperature, and then this dew point temperature, when reach out, that condensation nuclei around it, the water molecule gather, become bigger, and then through the gravitational force if actually fall down. That's rain, liquid water, rain. Snow form when we talked about that deposition, sublimation deposition, you remember that. So snow form due to the deposition process. That's mean the water vapor actually directly becomes solid, and that solid is snow, and this hexagonal crystal way, that's snowfall. And the sleet is something that the water rain actually, when falling down from the sky, it is actually passing through a very cold layer of the atmosphere, and then it directly become ice crystal. That's sleet. So sleet need to form, and that water droplet need to pass through a very cold layer of the atmosphere before fall to the ground. So if that's the rain fall into or pass through into very cold atmospheric layer, it will become sleet. So hail is something form that the turbulence when it happens, when thunderstorm happens, that's mean you have updraft, very strong updraft of air. That's mean one raindrop go, the updraft taken away or taking up, and then it become a smaller droplet of ice, and then it's falling down, then again the updraft wind take away. So this cycle again and again make the ice crystal, the hail, bigger, and then it's fall down. So those are the mechanism of each of the precipitation. So the mechanism responsible for the most of the precipitation. So we know that you need your air need to go upward and then become condensation, relative humidity increase, temperature decrease. This is the process most of the precipitation form mechanism. So you need to know these things because you have a question on that. So air mass source and classification, you have actually 2 or 3 questions from these air mass. So how air mass is determined? So we know that air mass has 2 letter code. The first letter start with either M or C. The second letter is capital letter, either E, T, P or A. So first letter is lowercase. M, when you see the M, any air mass start with the M. That means that air mass has moisture content. Any air mass, the first letter start with C, that air mass is dry. So that's the first letter says moisture content. The second letter is telling you the temperature situation. This E means equator. So equator is situated over the equator, and that's mean a lot of incoming solar radiation, hot situation, so very warm. T, tropical. Tropical also hot, but relatively not as hot as equator. P is polar. Polar means cold. Definitely polar area, higher latitude is cold. So Arctic, A, very cold. And most of the time when we see the Arctic air mass, is very cold and dry. So what is air mass then? From the 2-letter code we can know the air mass is a large body, subcontinental in size, of air that has the similar temperature and similar moisture content. So we would say that is the air mass. So in the United States you have those types of air mass: CP, CT, MP, all this. So in the United States, if you are looking at the maritime MP air mass over here, maritime, let's see the next. So over here, if you see cold, dry, starting with A, Arctic, and then cold, dry, continental, polar. So that's why dry, because it's starting from continent. So any air mass producing from over the continent, that would be dry. So you have continental, tropical, another one hot and dry. Because of the T, tropical region, it would be dry, so that's why it's hot. You have cold, wet, MP, maritime, polar, both side, west and east side, you have maritime, polar. So cold and wet. Why it is cold? Because it's polar. Why it is wet? Because it's starting with M, maritime, producing that air mass from the water body and carrying out a lot of moisture content. That's why it's MP. You have wet, warm, MT, maritime, tropical, that's warm and wet. So all this air mass you have in the United States, but United States weather actually does not affect of equatorial air mass. So you don't have any equatorial air mass in the United States. Most of the time the equatorial air mass is related with the formation of hurricane. So you need to know that what is air mass, what does the 2-letter code represent in air mass, moisture content, and you also see that the Arctic air mass, you have CP air mass. When it pushed down all the way to the United States, you have a Rocky Mountain over here, you have a Appalachian Mountain over here. So when sometime polar vortex become weaker in the winter, so that air mass pushed down all the way to the south, and you see in the very cold weather sometime in Oklahoma you will see a lot of snowfall. You have had that a couple of days ago.